Hello and welcome to week 4, lesson 1. We're going to start solving one-step equations. Before we can do that, though, we're going to have to look at the algebraic properties of equality, which are needed to solve one-step equations. And before we get to that, we have to talk about what inverse operations are. So inverse operations are operations that undo each other. Think of it like pizza. If I would go buy a pizza for my family, all right, let's say my parents send me out to buy pizza, forgot to give me money, and I have to spend my own money to buy the pizza. But when I get home, they give me the money back. Them giving me the money back undid me paying for it. So I ended up money-wise the same. It undid what I did first. In math, inverse operations are ones that undo each other. So addition, what undoes addition is subtraction, and vice versa. Subtraction undoes addition. Multiplication undoes division, just like division undoes multiplication. We're going to use those the most first semester. When we get to second semester, we'll look at how exponents, or specifically the exponent of 2, and the square root undo each other. These are important relationships to know, because without these, you wouldn't be able to solve equations. In algebra, you got to remember the goal is to solve for the variable. And the way we solve for a variable is being able to isolate the x on one side of the equation. We need to move numbers that are attached to x. And you will see numbers being multiplied by x, divided with x, added and subtracted with x. And we have to know how to move those away so that we can solve and get a value for x. What we need to remember with equations is that they have to remain balanced. So when you get an equation such as x minus 4 equals 10, and you know that it's balanced, you have to try to find what x equals. Well, to get x by itself, we have to follow properties of equality. And some of those properties are addition property, subtraction property, multiplication property, and you probably guessed it, division property of equality. And we're going to look at each of those next. So the addition property of equality, what does it say? It says if you have 3 numbers, A, B, and C, or 3 numerical expressions, or even algebraic expressions, A, B, and C are all expressions. If I have 2 expressions equal to each other, then what I can do is I can add another number to the left side and the right side, and the 2 expressions remain equal. I'm going to use a really easy example to show you what that looks like. So 7 equals 3 plus 4. We know that that's true. 7 and 3 plus 4 is also 7. So A is 7, B is the expression 3 plus 4. Those 2 things are equal. Well, if I decide to add 2 to the left side, I got to add 2 to the right side, and what this is saying is the 2 sides will remain equal. And let's look. 7 plus 2 is 9. 3 plus 4 plus 2 is also 9. Now, where does that show up when it comes to solving algebraic equations? Well, let's look at this one. I just said this one a little bit ago. X minus 4 equals 10. I need to get x by itself. So what do? I got to move that negative 4. So I'm subtracting 4 from x. The inverse operation of subtraction is addition. So I'm going to add 4 to the left side. And what that does is it will make negative 4 and positive 4 undo each other. But I can't just do that. It doesn't follow the property of equality because I added 4 to the left side. I didn't add it to the right side. So that's why I have to add 4 to the right side as well. And what that gives me is x plus 0 on the left-hand side and 14 on the right-hand side. Well, we know x plus 0 is just x. That's the additive or the identity property of addition. So x equals 14. And we've just figured out the value of x. The subtraction property of equality is very similar to the addition property. If I have A, B, and C, and I have A and B equal, then I can subtract C from both sides, and the 2 expressions remain equal. All right, so 6 equals 6. If I subtract 1 and subtract 1, they remain equal. Okay, so how does that one show up in algebra? X plus 6 equals 15. I need to undo that plus 6, so I subtract 6, but then I have to do it to both sides. So 6 minus 6 is 0. 15 minus 6 is 9. X plus 0, again, is just x, and I have solved my equation for x. X equals 9. The multiplication property, A, B, and C again. then I can multiply C by both sides. You're hopefully noticing a pattern here. Okay, so we'll look at x divided by 2 equals 20. That's an equation. The expression x over 2 is equal to 20. Well, I'm going to multiply both sides of this equation by 2. Why 2? Well, the 2 will cancel. Right? 2 divided by 2 makes 1. And then 1 times x, that's the identity property of multiplication. So I'm left with just x on the left-hand side. And then I have to do 20 times 2 to get my answer for x, which is 40. The last property of equality is division. Okay? You guessed it. I can divide both numbers or both expressions by c. Now, there's one additional thing I want to say. You cannot have c be 0. C cannot be 0. It's the only thing it cannot be. Other than that, you can divide by c. So, how does that show? Here's an example. 10 times y equals 450. That's multiplication. How do I undo multiplication? I divide. So I'm going to divide by 10 on both sides, and that's going to make 10 divided by 10, 1. 1 times y is y. 450 divided by 10 is 45, and I have solved for y. And that concludes lesson 1, one-step equations. In the next lesson, we'll look at two-step equations.